Thank you for being here. And I want to begin by saying, first of all, I've only been in California about 2 years, so I'm going to say right up front that I don't know as much about California groundwater as some, or perhaps many of you do. So what I want to do today is to take a few minutes and talk about what I have worked on in one realm, and that's the intersection of resource extraction, particularly oil and gas extraction, and groundwater availability, and particularly groundwater quality. And I'm going to work my way east to west. So we'll start sort of in the Marcellus on the east coast, and then we'll work our way through the center of the U.S. to the state of California at the end. So though many of you have seen an operation like this, this is a picture I took from a helicopter overlooking near Marcellus. And what you see there is a hydraulic fracturing operation that's visible. You're looking down from the compressors, the trucks and such, and then you see that house in the background. And that's a little bit different than some of the resource plays in California, but it's that intersection of close industrial activities and where people live that generates some of the controversies around this activity. And think about how your perspective on that option might differ depending on whether you own the mineral rights or not, for example, to that activity that was happening right next door to you. As Leon mentioned just very briefly, wear a couple of other hats. I chair an organization called the Global Carbon Project. We release an annual carbon dioxide budget and now a biannual methane budget. And then we also do in our group a lot of work on video imaging well pads. We just published a paper where we flew 8,000 random well pads across the US to visualize leaks using infrared cameras with EDF. We have a project in the Marcellus and now here in California looking at emissions from abandoned wells. So legacy issues, what are the things we're doing sort of 25 and 50 years from now that might make a difference? And then with colleagues in Boston, published the first publicly available maps of natural gas leaks. So we put laser-based instruments in cars and drove every block of cities like Boston and Washington, D.C. and Manhattan and showed how pipeline replacement programs can really make a big difference. So that's Boston in the lower right there, and each of those yellow spikes is a gas leak that we mapped. All right, so let's talk about water. The intersection of oil and gas extraction, resource extraction, drinking water aquifers. I want to begin by just thinking about where concerns might arise. So when you look at a schematic like this, you see the potential for spills. My first job out of college was with the Dow Chemical Company. So surface safety was first and foremost what we thought about. You can see rivers, streams nearby through which spills might go into. You can think about well integrity, which is something I'll talk about briefly, the tried and true issues of cementing and casing and how we protect drinking water aquifers from oil and gas extraction and activities that pass down through them into the underlying layers. And then in most cases, off the bottom of this screen is the hydraulic fracturing activity and other acid and other treatments that we use. But I'll also talk a little bit today about how in some cases that activity gets pretty close to the surface and close to shallow drinking water aquifers. So that's sort of where we're going. I'll begin just by providing one example from the Marcellus. As Leon mentioned, we did the first studies with my colleague Avner Vengosh at Duke of drinking water quality and hydraulic fracturing. So this is northeastern Pennsylvania, an area that had not had a lot of oil and gas extraction prior to the hydraulic fracturing increase in the late 2000s. This is the state border with New York. So that's like a fence line comparison because, as you likely know, New York had and still has a moratorium on high volume hydraulic fracturing, so that we can use this state line comparison almost like a fence line comparison as you would in a field to look at similar geology but different practices across that area. So each of these dots is a house. We walked up the driveway and sampled the water quality in that house and looked at what was in that water chemically and oil and gas activities nearby it. Now what we found was, first of all, that in most cases we did not find evidence for contamination at all for things that people were most concerned about, including radioactivity. For instance, salts and metals. In a minority of cases, in a small minority of cases, we found evidence, strong evidence for stray gas contamination. And I'll only have a couple of graphs today, but as you move close, from far away on the right here to close to an oil and gas well, each of these dots is a home. The gray band is the hazard mitigation action set by Department of Interior. And if you're above this band, your water bubbles like champagne when it comes out of the faucet. So what you see here is that in a minority of cases, you see very, very high, even supersaturated methane levels above and only within 1 kilometer or so of that oil and gas activity. And beyond this, there's random variation, naturally occurring high levels of methane. Ethane's even stronger because, of course, there aren't biological sources of ethane and propane. So it's really tighter. You see basically a flat baseline, and only within about this 1 kilometer area do you see, again, in a minority of cases, these kinds of interactions. So what happens? What goes wrong? Well, there are lots of different mechanisms. In a few cases, we had abandoned wells that intersected current activity, and it's an issue for California. We have very, very high well densities in some of our extraction areas. You could conceivably, with the hydraulic fracturing operation itself, open cracks all the way to the surface, particularly if you had a fault, for instance, that ran like this. But that isn't what happened in the vast majority of cases. In the vast majority of cases, we just had the same old issues that were true for oil and gas extraction over the last decades. We had people being in a hurry, we had cementing issues or even a lack of cement, poor cement quality, casing that was cracked. So these well integrity issues are the things that I believe are the most important explanation for these cases of stray gas contamination that we identified. So let me just show a couple of other places we've worked quickly and what we've learned there. And I want to talk about these as exceptions because I think these unusual cases are where we can learn something. And by not focusing on these, by ignoring these, we lose the opportunity to understand, again, the minority of cases where things go wrong. Here's a high-profile one in Texas that some of you know about, Parker County. This was one where the EPA was involved initially and stepped away from that investigation. The homeowner on the right claimed that his faucet, he could light his faucet on fire from the gas that was coming out of it. So that was disputed. So we did some sampling over the course of a year in the surrounding area in that neighborhood. And so here you have just a couple of examples of gas that over the course of the year was very, very low concentration. By the end of that sampling period was super saturated. So we were able to catch that transition as it happened. Are we on the wrap time? Is that what you just flashed me? No, you just flashed me the wrap sign. So anyway, these are the cases where over time, we didn't always have a pre-drilling record to compare to. In this case, though, we caught that transition as it happened. All right, so what's going on here? Well, in this case, you had cement that was missing for about 4,000 feet from this operation. Right, so that provided essentially, if you would, a chimney or a pathway where pressurized gas from intermediate pockets could move up that well and then out into the drinking water, even if that cap of seal is in place at the top in the drinking water layer itself. So best practices differ. Not all companies in the area do this. But again, some companies do. Sometimes we get in a hurry. One other example, continue to move west to Wyoming. Another high-profile case, Pavillion, Wyoming. This was a paper we published earlier this year. And I know that's a little hard to see. This is sort of the depth. So here's the ground surface here. These two blue lines are the depths or the maximum depths of private water wells in this area of Pavillion. Well, that's about 750 feet or so down here. And you're looking at a time course of 50 years of oil and gas extraction in that valley. So you have typical conventional wells, you had acid matrix treatments that came into play here, then you had the higher volume hydraulic fracturing that happened here. And what you see is an increasing shallowness of that activity. So you have people in that area getting their water from wells 750 feet underground, and acid matrix treatments happening at 800 feet underground. Hydraulic fracturing happening at 1,000 feet underground. So you lose that buffer, if you will, that protective buffer that you have when hydraulic fracturing and other extraction activities are a mile or two underground, which is the way it typically occurs in the eastern U.S. in traditional shale layers. So in this case, it's much shallower than we're used to thinking about. There are lots of other things going on too. You have a legacy of unlined pits. So there were dozens of open wastewater pits that were used that resulted in chemicals leaching into the soil and into groundwater. You had insufficient vertical separation, as I mentioned just a minute ago, between the drinking water and the chemical treatments. You have stimulation fluids that were injected directly into underground sources of drinking water, as defined by the EPA. And then much more that would not qualify as best practices. Okay, and then just a few minutes in California then, as I mentioned, where I've been here for 2 years now. California has some similarities and some differences to the previous examples that I just talked about. And the biggest similarity to the Pavillion, Wyoming case is that we have many, many cases of oil and gas extraction that are much shallower than you see in the eastern U.S. typically. So half of the hydraulic fracturing in California occurs above about 2,000 feet to as shallow as about 850 feet in places. So on the other hand, our water use and chemical intensive nature of hydraulic fracturing in California is relatively low. We don't have a lot of long, several kilometer, mile-long horizontal legs because of the sort of the tortured geology that we have and the folding and such that's occurred. So very shallow, relatively speaking, not as water and chemical intensive on a point-by-point basis. But this is a paper we did last year where we compared the depths of hydraulic fracturing and accompanying water use for every state in the U.S. that was producing oil and gas. And California is quite shallow. So this intersection potentially between people, farmers, municipalities getting their groundwater increasingly deeply in California and oil and gas activities that are increasingly near the surface is one of the concerns that I had that led to this study that came out earlier this year. This was work led by Mary Kang, a postdoc in our group. So we used DOGGR wells, information of about 1,000 cores for chemistry and depth data for about 30 or so thousand oil and gas wells. To look at the chemistry to try and estimate a budget for where fresh water is available deeply and where the oil and gas extraction is. So where it is vertically, spatially, and then where the groundwater is of sufficient quality to be used or categorized as fresh water or legally as USDWs or usable water by the BLM. So we found budget-wise that there's 2 to 3 times more fresh groundwater than is available if you just consider the top 1,000 feet. Most of that additional water is between 1,000 and 3,000 feet, still relatively expensive to extract, and should not be used as a justification to keep us from conserving that water. The increased pumping will worsen ground subsidence, particularly in areas where there are clays that compact. And then finally, somewhere between about 20% and a third of all oil and gas activities in some counties, Kern in particular, are occurring directly in either fresh water or USDWs. So that's something that I hope to continue working on in the context of oil and gas extraction, underground injection, and other things. So a few points for discussion. SGMA and the well stimulation bill both mandate additional data collection, but their emphasis is on shallow aquifers primarily. So I was part of the committee that Brad Esser led for SB4 on the well stimulation bill and groundwater monitoring. We should be banking in California public water data every time an energy or a public water well is drilled. So collecting much more data, making that data publicly available, and then examine safeguards and perhaps approval processes for energy wells drilled shallower than 2,000 feet, say, and resource extraction and class 2 injection wells. Thanks very much.
Thank you, Rob. Rosemary?